Hey, let's take a look at enzymes. Enzymes are critically important organic catalysts. They do the job of speeding up reactions that normally would take too much energy to be spontaneous in a living system. Enzymes react on materials referred to as the substrate. The substrate is the reactant that's being acted on. Okay? And enzymes are substrate specific. One enzyme for one substrate, one enzyme for one reaction. Let's take a look at how enzymes work. Enzymes can break down substrates. So here we have sucrose. We've got a glucose and fructose bonded together here. This particular enzyme meshes with them, causes them to become unstable in their bond, breaks them apart, and the products are released. Notice the enzyme itself is not changed. However, the sucrose is now broken down into glucose and fructose. Enzymes can also put things together. So enzymes can be catabolic or anabolic. Okay, so here we have the substrates, two pieces of raw materials entering the enzyme's active site. Okay, when they leave, they are now bonded together in a new product. And notice, again, the enzyme hasn't changed. Okay. How do enzymes work? Enzymes work by reducing the activation energy in a reaction. So here we have a typical graph of a reaction. Here we have the reactants. On the right-hand side, we have the products. Okay? And this insurmountable energy hill is referred to as the E sub A, or energy of activation. What the enzyme does is lowers that E sub A. Okay? So here we have in blue the uncatalyzed reaction with the insurmountable activation energy. Here in red, we have the catalyzed reaction that is being aided by an enzyme. Okay? And notice we have, that's about 30%, 40% of the activation energy of the original graph. This, now, the cell is able to overcome in terms of free energy, and will push that over the hill so that it will proceed spontaneously to the products. Enzymes are sometimes referred to as a lock and key. Okay, we have one lock fits one key. Okay, you've got separate keys for separate locks, and therefore the analogy helps us to remember that enzymes are substrate specific and will not interact with other substrates. Okay. There is one thing about the lock and key that is, well, needs to be dealt with just a little bit. Okay. And that is that the substrate binding region is referred to as the active site, but it's not a perfect fit. Okay. It's not a perfect fit. So the enzyme substrate complex is sometimes referred to as an induced fit. This induced fit, so here we have a blue enzyme here and a reactant. This isn't a perfect fit. The key in this instance and the lock have to be jiggled, and they've got to force together. If it doesn't fit, force it. Okay, so it's referred to as an induced fit. This puts a physical strain on the reactant, causing it to be unstable in its current configuration, and that is the instability that causes the reactant to change. The enzyme provides that induced fit instability that forces the reactant to change into the products. Here's another little picture of the induced fit, referred to as the transition state. Okay? And there's a physical twisting there. There's a physical pressure there that causes that to be unstable and causes it then to need to change. That's enzymes in a quick manner, and I hope that was helpful. Thank you.